Hello everyone and welcome back to Project Euler. I know it's been a while since I uploaded my last video, but truth be told I just got really bored of running through things in chronological order. So instead of doing problem 5 in this video, I'm going to be doing problem 18. If you don't like it, suck my fat meaty balls. I don't care, this is my channel. I'll do whatever I want. But anyways, let's move on. So this is Euler problem 18. I forgot what it's called. I'll just explain it to you. So we have a triangle of numbers. We have to start at the top of the triangle, and every time we move down onto the next row, we can choose one of the two numbers directly below us. So number directly to the left or directly to the right on the next row, right? And we need to find the path with the largest total. I'm going to start with this small example, which is the one that I've got typed up here. But later we're going to go for a big example, which just give you a sneak peek. Ooh, that was a pain to type. Anyways, so looking at this one, the best path here is 3, 7, 4, and 9. Because if we look at these two options, 7 is bigger than 4, so we move to 7. 7 has the options of 2 and 4. 4 is bigger than 2. Bang. And if we look at the options for 4, 5 and 9, 9 is bigger than 5, we choose 9. So 3 plus 7 plus 4 plus 9 is 23, right? So we want to think of a way to store the triangle. And to do that, I'm going to use a list for the whole triangle and another list for each row. So this is the list for the whole triangle. And then we're just going to put the list for the rows inside of it, which AI Overview is graciously filling for me, right? So as you can see, the first inner list is the top row, second inner list is the second row, and we go down to this on the last inner list, right? So one possible solution would be to try every path, which I would say is actually the better solution for a small triangle like this, because it's easier to implement and the speed difference is negligible between this and the better solution. And that is to check every single possible path, to brute force it essentially. But the issue with brute forcing, and the reason that I don't want to use it, is because say if you have a triangle with 100 rows, well, you have to think about how the number of paths increases with each row, right? You have two options from each number. So, you know, if I was to add another row down here, then each of these paths would have two different paths that it can split off into. So essentially, the number of paths possible doubles with each row. So if we had like 100 rows, then correct me if I'm wrong, but the number of possible paths would be approximately 2 to the 99, which is this ridiculously big number. And you can just see that brute forcing quickly becomes computationally infeasible or unfeasible, whatever the word is. But anyways, right. Instead of working from the top down, we're going to work from the bottom up. We're going to use our big, massive brains, and we're going to work from the bottom up to make things more efficient, right? So let's look at the two bottom rows. From 2, I can move to either 8 or 5. 8 is larger, so the best total is 2 plus 8, which is 10. We look at 4, best total is 4 plus 9, which is 13. We look at 6, best total 6 plus 9, which is 15, right? And now that we've generated the best totals from these two rows, we can actually just slash them out and bring this onto the bottom of the triangle, because, you know, no other paths that we could have chose from these two would be any better. So now what we can do is from 7, we can look at 10 and 13. We're going to ignore the top row again. We're going to look at the bottom two. So from 7, 10 and 13, 13's bigger, so we get 20. 4, 15's bigger, we get 19. And now we can slash these two rows and just put the 3 on it. And you'll see from here, now we only have 2 options. And 20's bigger than 19, 3 plus 20 is 23, which you can see is the best solution here. So this clearly works. So how do we implement it? Well, first thing that we want to do is make a copy of triangle, because, you know, really bad practice would be to do this. The thing is, if you're working on data, it's kind of like, it's almost always essential to keep a copy of the original, because most operations you can't reverse. Like if we merge these two rows together, then you'll genuinely have no idea what they originally were, and you can't figure that out from 10, 13, and 15, or whatever it was, right? So we're going to make a copy instead. And the way that we're going to do that is with this line here. And, you know, this just goes through every row and copies it. Best totals contains the exact same numbers as triangle, but now we can change it without changing triangle. Right? Cool. So, we're going to move upwards through the rows, and the way that we're going to do this is by doing this. Ooh. Let's get rid of that. Right. So, this loop moves backwards through the rows. In our example, it visits row 2, row 1, and then row 0. You might be confused as to why I'm calling the first row in the list row 0, and that's because clankers, they zero index things, which means that we start counting from 0 rather than 1, like humans. So row 1 is actually row 0 according to the clanker, row 2 is row 1, row 3 is row 2, and row 4 is row 3. If you don't understand that, get used to it, because nearly everything does it. But yeah, let's move on. Okay, so now we need to visit each number in the row. And to do that, we're going to write this line of code right here. I don't know why my indenting looks like that. It's really annoying me, but I will live with it. I really need to turn this AI thing off, but anywho. The variable called position tells me where the number is inside of the row. For example, in the row containing 2, 4, and 6, just choose a random one. The positions are 0, 1, and 2, right? Because of the thing I said about clankers counting from 0. And we want to look at the two choices below it, right? And we're going to call them left child and right child, just because that's a nice way of naming things. You don't essentially have to understand what a child and a parent is, just brush, right? So the left child is on the next row and in the same position. If you want to know why, just think about it. So this is the 0th item in this row, and this is the 0th item in this row. And as you can see, it's to the left, if we look at it in this visual. And the right child, well, let's have a look at this again. From 7, the right child is 4, it's on the next row, and this is position 0, while this is position 1. So we're going to do row index plus 1 and position plus 1, where position refers to the position of 7, right, in this case. So, now what we're going to do is we're going to look at the best child. So we're just looking for the bigger one, right, and we're just going to use the max function. I love how simple Python is. It really gets me going. Anywho, yeah, the max function returns a larger value. If the choices are 5 and 9, it returns 9 as an example, you know? So, we're going to update the current number. So, we're going to add the larger child to the number I'm currently processing. We're going to do best totals, row index, position, to retrieve the one that we're currently looking at, plus equals best child. So plus equals means take the current value and add best child to it. So, 2 becomes 10, 4 becomes 13, and 6 becomes 15. That's the line that does that, right? And then the program will move upwards and repeat the same process, right? So I'm going to temporarily print the triangle after each row is completed so we can see it changing. So if I just print best totals, oh wait, we want to move this down, whoops. Let's have a look at the output. So you can see the way that the rows are getting merged, right? So we end up with 10, 13 and 15. From merging the bottom two rows, we get 20 and 19. From merging this row and this row, and then we get our 23, which is the solution! Woohoo! Right, okay. So, the final answer is the first number in the first row, right? So if we just print this, for this specific triangle, whoa, what was I saying? For this specific triangle, we get 23, right? Which is fantastic, that's the answer. Okay, so, now that we've done it for this puny, pathetic little triangle, hold on, let me just make the... Oh, that's very nice. But, oh wait, no, I don't think the AI is doing what I'm looking for. Let me do it myself. The maximum path sum is that. Just to make it a bit more readable, I'm going to throw this on its own line. So we'll do answer equals this. Answer. Right. Happy? Great. Oh yeah, I don't need that space there because it's comma concatenation. Anyways, right. So, instead of doing this for this puny little pathetic triangle, this tiny little thing, this disgusting little thing, we're going to go down to this big beefy hunk down here, and we're going to use this one. And look at how fast it moves. Look at how beautiful and sexy it is. So, if we do it for this triangle, watch what happens. And just like that, we get the answer. Ignore all of these other ones. It's just because I did something stupid with the indentation. Should be like that, I think. Oh wait, no, actually. No, it should be. Yeah, there we go. Fixed. And that is the solution. And as you can see, it's incredibly fast. As soon as I click run, it's already finished. Beautiful. And if I did this for hundreds and hundreds and hundreds of rows, it would still be quick. Because we're skipping so many steps by doing this. Yeah. So, that's the answer. I hope that you have found some kind of insight for this video. I hope you enjoyed it. And whoever this was made for, you know who you are. I hope you like it. Bye-bye, everybody. Have a good one. See you next time.